This is Algebra 2, Lesson 58. All right, so today's lesson is more on completing the square. But instead of having a lead coefficient of 1, so what do I mean by lead coefficient? What does that mean, Therese?
Is it a root to x squared?
Yes, it's the coefficient with the highest exponent. Term with the highest exponent. So it is x squared for quadratic, for sure. A monic lead coefficient means it's 1. But now we are going to have a number other than 1. So the only difference is you have to factor out that lead coefficient. All right? Again, the way that I work it is not like your textbook. They move the constant to the other side. I do not move the constant to the other side. You actually could with these, but I don't, because when we get to graphing, you're not going to move that constant to the other side. All right, that helps us to know where the vertex is. All right, so completing the square with a lead coefficient other than 1. Example 1 on page 249. All right, just like we did when we had a monic lead coefficient, we're going to separate that 3 out and put these two terms, the x squared and the x, together. All right. Now, what's inside the parentheses, we're going to factor out the 4. Remember, factoring is just like division. So inside the parentheses, our b value is now 3/4. So oftentimes you're going to have a fraction. All right, what did we do to this b term? We took half of it and squared it, right? Normally we divided by 2 and squared it, but I'm going to say it's 3/4 times a half, because we're taking half of it, right? And then we're squaring it. All right, so that ends up being 3/8 in the parentheses. When we square that, it's 9/64. Okay, here's the tricky part. You ready? We add inside, we subtract outside, right? But I can't just subtract 9/64. I have to subtract 4 times the 9/64, because 4 has been factored out. So you're always going to multiply by what's outside here. So I'm going to subtract 4 times 9/64. You see the slight difference? Whatever you factored out, you're going to multiply by your half b squared. All right, so now we're still left, don't lose your 4. That tells me something about what the curve looks like. It's actually a vertical stretch. It makes it, the bigger the number, the skinnier the parabola. If outside there were a 1/2, it would be a wider parabola. So this tells me visually what the curve is going to look like. It's almost like a slope, right? Almost like a slope. All right, now what is left inside here? What's inside my binomial squared? Same thing, half a b. So it's going to be plus 3/8. And I am going to simplify. 4 goes into 64 what? 16 times, right? So I'm going to make this one 16/16. And that's going to be minus 9/16 equals 0. I'll combine these. Does 3 go into 16? No. What's 3 times 16? 48. All right, so this is 48/16. So 4 times x plus 3/8 squared minus, what's 48 and 9? 57, right? 48 and 9?
Never mind, I can't do that.
Is it 57? Confirm.
Yes, it is.
Thank you. Over 16 equals 0. So now I'm back where I was going to be before, except I still have this 4 out here, so this is going to make a difference. I'll add the 57/16, so I'm left with 4 times x plus 3/8 squared equals 57/16. Now, because I have a fraction on this side, I want to move the 4. Remember, I want to isolate what's squared before I take the square root. I don't want to leave 4 on this side. So I could divide by 4, but is there another choice that I could do? Instead, yes.
You could multiply it by 1/4.
That's exactly what I'm going to do. I'm going to multiply by 1/4 on both sides, because that also eliminates the 4. And I'm left with x plus 3/8 squared equals 57/64, 4 times 16. Now I take the square root of both sides. On the right, it's plus and minus. Don't forget that. So I'm left with x plus 3/8 equals plus minus. Remember, when I have a fraction under the radical, it's the square root of the numerator over the square root of the denominator. I'm going to unsquare the denominator. What's the square root of 64? 8. So you're left with square root of 57 over 8. Okay, this is always the pattern typically with these types of problems. The denominator here inside your binomial squared is always going to be what you end up with here. That's a pattern. Subtract the 3/8. X is negative 3/8 plus minus square root of 57 over 8. All right, so only difference is after we isolate, we factor out that lead coefficient. When we subtract outside the parentheses, we have to multiply by what we factored out. Does it make sense why we have to multiply by what we factored out? Because really what we added is 4 times that value if we redistributed the 4. Does that make sense? No? Yes? Maybe? A few said yes. Does everyone understand this? All right. Then instead of dividing by 4 when you have a fraction on the right hand side of the equal sign, you're going to multiply by the fraction 1/4. Okay? All right, let's look at the next example. There are only 2. All right, top of page 250. 5x squared minus x minus 2 equals 0. And before we begin, it must be in proper form. Your quadratic has got to be in proper form. I'm struggling staying inside the camera. All right, so we'll isolate the x squared and the x. Move the 2 on the outside of the parentheses because we're not factoring out of the constant. All right, then we will factor out the 5. And we end up with 5 times x squared. This is really just 1/5 x minus 2. I'm going to remind myself I'm going to multiply by 5 out here, something that I'm subtracting. All right, so I take half of the 1/5 and square it. What is that? 1/100th. So we add 1/100th, we subtract 1/100th. What's my binomial squared? Yes?
Sorry, why do you subtract the negative? Why do you subtract the 5 outside the parentheses?
Because what we add in here, we subtract out here, so the net effect is 0. Got it? I added 5/100ths, I subtracted 5/100ths. Otherwise, I change the value of the equation.
Wait, so okay, this is like, so you wrote that subtracted 5 first. So
Right,
why
to
did
remind me, I'm multiplying by 5. Whatever I factor out, I'm multiplying by.
Oh, okay, I see. Thanks.
Make sense? So the net effect, what I've done here is added 0 to the left side, right? Added 5/100ths, subtracted 5/100ths, yes.
I didn't get how you factored out 5.
You always, whatever your lead coefficient is.
But there's no 5 in negative x.
It doesn't matter. It only matters what's with your x squared, what your coefficient of your x squared is. That's what you're factoring out. But when I factor it out, I still have to divide every term inside these parentheses by 5. Factoring is division. So I end up with 1/5 x. Okay, if I multiply 5 times negative 1/5 x, what do I end up with?
Negative 1.
The original, right? Does that make sense? So you're taking that lead coefficient, dividing your x squared and your x by that. All right, is everybody with us up to this point? Okay, what am I left in my binomial squared?
X minus 1/5.
1/10.
Why is it 1/10?
Oh, yeah.
It's just what's inside these parentheses. X minus 1/10. Because x minus 1/10 squared is what's inside the parentheses here. Yes.
And a perfect square will never have 2, or if that's what it's, never have 2 negatives. Not necessarily a perfect square, but if the x squared minus 1/5 x plus 100, that will,
This will always be plus.
yeah.
Because when I square it, it's going to be positive. When I square negative, it's going to be positive. That's why this is always positive inside here. Yes.
In all problems, or just the
100%. 100% of completing the square. Because it doesn't, when I take a half and I square it, that's what I'm adding here. And when it's a negative squared is a positive. Makes sense? So this will always be positive. This half b squared will always be positive.
It'll never be negative, and then the other one be positive? But that one, alright.
Okay. This one will never be negative. This one can be positive. And we're going to have them with that. But not today. Okay? Not today. It's when our lead coefficient is a negative number and I factor out a negative. Then it's a negative times a negative, okay? But we're not doing that today. All right, so this one, 100% of the time, that third term inside the parentheses will be positive. This one can change based on what we factored out. Okay? All right, so I'm gonna, 5 goes into 120, right? So it's minus 2. I'm gonna multiply that by 20 over 20. Minus 1/20 equals 0. So that's 40, and one more is negative 41/20. So I'm going to add 41/20 to both sides. Make sense what I did? You with me? So I'm left with 5 times x minus 1/10 squared equals 41/20. What do I want to do next? From here.
Multiply by 1/5.
I want to move this 5 to the other side. I'm going to multiply by 1/5. What's 1/5 times 5? 1, right? So that this eliminates, I'm left with x minus 1/10 squared equals 41/100. Now I take the square root of both sides. On the right hand side, it's going to be both. Y'all are slow. Plus and minus. Right? It's like pulling teeth to get you people to talk this morning. All right, so I'm left with x minus 1/2 is plus minus the square root of 41. I'm going to unsquare 100.
1/2.
I know. I don't know where I got 1/2 from. And it's over 10. I'll add the 1/10. So it's 1/10 plus minus square root of 41 over 10. This is my solution.